This video is going to compare the energy, current, and power in a series circuit. So here's my example series circuit, two equal resistors, 10 ohms and 10 ohms, and a charge will move across it. So there's our series circuit. Now, as a little bit of review, remember that power is directly proportional to the current flowing through the resistor times the potential difference, and the potential difference lost across the resistor is equal to the current flowing through it times the resistance of the resistor itself. Let's look at a little different circuit so we can see some relationships. I got a 5 ohm and a 10 ohm resistor in series. And I know by definition when it's in series, they're each going to lose the same or use the same amount of current. That is, the flow of the charges moving through here is going to be the same. So I've got 5 ohms on the top, 10 ohms on the bottom, and I know the two currents are going to be the same. It's going to come with this now. So now I've been able to compare the currents. They're going to be the same for resistors in series. Let's look at the energy, and I'm going to use voltage to measure the energy. So at the top of the circuit, I have some initial voltage. Let's call it V0. At the bottom, I'm going to have some other voltage. I'll just make it 0 to be easy, but really it could be any number because all we're looking at is how much is lost across these two components. So the original one, because voltage is directly proportional to the resistance, I know that the voltage of the 5 ohm is going to be 5 ohms divided by the sum of the two resistors, or 1/3 whatever the initial energy is. And the energy of the 10 ohm, which is the voltage, is going to be 10 ohms divided by the sum of the two resistors. So 10 divided by 15, which is 2/3 of the original voltage, or 2/3 of the original energy. So the 5 ohm resistor is 1/3 the total resistance, and it's 1/3 the total energy. The 10 ohm resistor is 2/3 of the original energy, because it's 2/3 of the total resistance in these two. So if I'm able to compare them to the original energy, now compare them to each other, I can just take 1/3 divided by 2/3. The V0s go away. So if I look at the ratio now, it's the energy of the 5 ohm divided by the energy of the 10 ohm is 1/2. And moving my numbers around, I can see that the 5 ohm resistor is twice the energy of the 10 ohm resistor. If I look at the power, I know that power is equal to IV. So the I divides out because it's the same current in each one of these. So the power is proportional to the potential difference across each one. So the 5 ohm resistor has twice the energy used up, so therefore it's also going to have twice the power as the 10. The other relationships also hold. If I compare the original energy, 1/3 of the energy is used up in the 5 ohm, 2/3 of the energy is going to, or the power is going to be used up in the 10 ohms.